Good morning, students. Welcome you all for next generation learning. Today we are going to see the subject physics and class 10, chapter number 11, human eye and colorful world. Topics: scattering of light, Tyndall effect, why is the color of the clear sky blue, why does the sky appears dark instead of blue to an astronaut, why traffic signals are red in color of the sun at sunrise and sunset, why does the sky appears white at noon? Then activity. The interplay of light with object around us gives rise to several spectacular phenomena in nature. Are you understand this line? This is the interplay of light with the object. When the light fall on the object, it gives some spectacular phenomena in nature. So what are the spectacular phenomena? The blue color of the sky, color of water in deep sea, the reddening of the sun at sunrise and the sunset are some of the wonderful phenomena occurs in the sky because of the interplay of light with the object. The Earth atmosphere is a heterogeneous mixture of minute particles. You know the meaning of heterogeneous? The heterogeneous is different type of particle. Homogeneous means same type of particle. Our atmosphere is made up of heterogeneous mixture of minute particles. What are that heterogeneous particles? Smoke, tiny water droplets, suspended particles of dust, and molecules of air. These particles are mixed in the Earth atmosphere. Scattering occurs when light passes through an imperfect medium, such as air filled with a particle of some sort, and are deflected from straight path. Are you understand this paragraph? Listen. When the light passes through the imperfect medium, why we say that the air is a imperfect medium? Because it consists of several type of particles like smoke, tiny water droplet, dust, and molecules of air. So the light passes through this imperfect medium. It deflected from a straight path. So that effect is called scattering. Listen this example. When the sun rays pass through the clouds, the light is deflected off its straight path and scatters in many directions. This is called scattering of light. Look at this image. Here, the sunlight hit on the clouds. When it hit on the clouds, the light rays are deflected from their straight path and it is scattered in many directions. This is called scattering of light. Are you understand what is meant by scattering of light? When the light fall on the object, it deflected from the straight path and scattered in many directions. This effect is called scattering of light. And scattering of light depends on the two factors. One is size of the suspended particle. The other one is wavelength of the incident light. We will see how the scattering of light will depends on the size of the suspended particle and also wavelength of incident light. First, we are going to see size of the suspended particle. You know that our atmosphere consists of heterogeneous mixture of particles. So the size of the particles varying from one particle to another particle. Maybe the size of the suspended particle is large means the scattering of light is more. The size of the suspended particle is small means the scattering of light is less. So the size of the particle is directly proportional to the scattering of light. Size of the particle large means the scattering of light also large. The size of the particle is small means the scattering of the light also small. The next one, wavelength of the light. In the one previous example, we saw that the sunlight fall on the kit on the clouds. So you know that sunlight is consist of 7 colors, not a single color. It consists of the 7 colors. You know that VIBGR. Each color has different wavelength. So what is meant by wavelength first? Look at the second diagram. The distance between the two crest or two trough is called wavelength. So the sunlight consists of 7 colors from violet to red. Here the violet has shortest wavelength, the red has longest wavelength. So longest wavelength scattered large size particle, shortest wavelength scattered small size particle. So what is the meaning of this? If you take two object, if you take two stone, example, if you take two stone, one is a large and another one is a small. So when the sunlight fall on the large size of the stone, this large size of the stone scattered the longest wavelength of red light. The same sunlight fall on the small stone means this small stone scattered the shortest wavelength of violet. Here the violet, indigo and blue are called as blue family. So it is scattered violet, indigo, blue, shortest wavelength. I hope you understood what is meant by scattering of light. The scattering of light depends on the two factors. One is the size of the particles and another one is the wavelength of the incident light. Here the sunlight is incident. It consists of the 7 colors. Each color has a different wavelength. The violet has a shortest wavelength. The red has the longest wavelength. Larger size particles are scattered the longest wavelength of red. The small size particles are scattered the smallest wavelength, that is the shortest wavelength of violet. The next topic is Tyndall effect. So what is meant by Tyndall effect? Tyndall effect is an effect which is created by scattering of light by the particles in its path. Listen this example, then you can understand Tyndall effect. When a fine beam of sunlight enters a smoke-filled room through a small hole, the scattering of light makes the particles visible. So this effect is called a Tyndall effect. I think this situation is seen everybody in your life. And when sunlight passes through a canopy of dense forest, here tiny water droplet in the mist scatter the light. Due to that scattering of the light, we can see the particles present in that place. So this effect is called a Tyndall effect. The next one, colloidal solution. And look here. Look at this image. Here, a beam of sunlight enters a smoke-filled room through a small hole. So the particles present in the room scatter the light. Due to the scattering of the light, we can see the particles. So the scattering of light makes the particles visible. When we can see the particles, that effect is called a Tyndall effect. And the same as When sunlight passes through a canopy of dense forest, here tiny water droplet in the mist scatter the light. Due to that, we can see the particles present at that place. The next one, colloidal solution. A colloidal solution is a solution where the solute is suspended in the solvent. Here I took for the two beakers, the one is pure water and another one is a colloidal solution. And I take the laser beam. When I allow the laser beam in the beaker of pure water and a colloidal solution, the light beam is not visible in the pure water because there is no particles present in that pure water. There is no scattering of light. In a colloidal solution, light beam is visible. How? Because in a colloidal solution, the particles are suspended. So these particles scatter the light. Due to that, we can see the path of the light. I hope you understood what is meant by Tyndall effect. The next one, why color of the sky is blue? Have you seen the sky, color of the sky? Yes. Everybody know that the color of the sky is blue. Do you know what is the reason? We will see the reason. Before going to see the answer for why the color of the sky is blue, you have to know what is meant by electromagnetic spectrum or waves. The electromagnetic spectrum or waves consist of 7 waves: radio wave, microwave, infrared wave, visible light, ultraviolet ray, X-ray, and gamma rays. And look this image. Here I written gamma ray, X-ray, UV ray, the visible light, that is BGR, infrared, micro, and radio wave. Earth block and allow EM waves. Fortunately for life on Earth, our atmosphere blocks out high energy radiation like X-ray, gamma ray, and UV ray. So these rays are not, our Earth is not allowed to, not allow. It blocks out the high energy radiation of X-rays, gamma rays, and UV rays. The atmosphere allows visible light, infrared wave, microwave, and radio wave. But out of these waves, visible light only visible to our eyes. Other waves are invisible. That means infrared wave, microwave, and radio waves are invisible to our eyes. We can see only visible light. And in the visible light consists of the seven colors, violet to red. The wavelength of visible light increasing from violet to red. You know that the violet have shortest wavelength and red have longest wavelength. So the wavelength of visible light is increasing from violet to red. The molecules of air and other fine particles in the atmosphere have size smaller than the wavelength of visible light. So comparing to the size of the wavelength of the light, the particle size are very small. There are more effective in scattering of shorter wavelength at the blue end than the light of longer wavelength at the red end. The red light has a wavelength about 1.8 times greater than the blue light. So comparing to the blue light, the red light has a wavelength about 180 times higher, greater. So when sunlight passes through the atmosphere, the fine particle in a air scatter the blue color shorter wavelength more strongly than the red longer wavelength. So the scattered blue light enters our eyes. So the sky appears blue. Normally, you know that in the small size particles always scatter the shorter wavelength of blue family. So when the sunlight passes through our atmosphere, there are more fine particles are present. So these fine particles scattered the blue light more than the longer wavelength of red. So which light is scattered more? Here the blue light is scattered more. So the blue light only enters into our eyes. Due to that reason, the sky appears blue. And look at this image. The sunlight, it consists of the 7 colors from the blue to red. When it falls on the atmosphere, the blue light only scattered more because of the fine particles present on the atmosphere. So the blue light only reach our eyes. So the sky appears blue. The next one, why does the sky appears dark instead of blue to an astronaut? And look this image. These are the astronaut peoples in the outer space. They look the sky, but the sky appears dark instead of blue. Why? Because there is no atmosphere in the outer space. There would not have been any scattering. If there is no atmosphere means there is no particles. If there is no particle means there is no scattering of light. No scattering of light means it looks only dark. So the sky appears dark to passengers flying at very high altitudes. The scattering is not prominent at such height. Why scattering is not prominent? Because no atmosphere. No atmosphere means no particles. No particles means no scattering of light. So that reasons the sky appears dark instead of blue to an astronaut. The next one, why traffic signals are red in color? The red light is scattered the least by air molecules. So red light is able to travel the longest distance. You know that in atmosphere consists of the fine particles. The fine particles scatter the shorter wavelength. So the longest wavelength of red is not scattered more. So it travel to long distance. So which travel the long distance, it reach our eyes. So the red light is able to travel the longest distance. So the traffic signals are red in color. The next one, have you seen the sky and the sun at sunrise or sunset? Have you wondered as to why? Yes, to why the sun and the surrounding sky appear red. So look at this two diagrams, two images. Here the sky appears reddish during the sunrise and also sunset. Why? Why it does not appear so blue or yellow and violet? It appears only red. What is the reason? We will see the reason. And look at this image. We are on the earth. So light from the sun near the horizon passes through the thicker layer of air and a larger distance in the earth atmosphere before reaching our eyes. Maybe this is the position of the sun. So this sunlight have to travel for the long distance, then only it will reach our eyes. So light from the sun near the horizon passes through the thicker layer of air and larger distance in the earth atmosphere before reaching our eyes. Are you understood this sentence? You are in the center and this is the position of the sun. uh, Here the sun is in the horizon place, so the sunlight has to travel for the longer distance to reach our eyes. Near the horizon, most of the blue light and shorter wavelength are scattered away by the particles. Therefore, the light that reaches our eyes is longer wavelength. This gives rise to reddish appearance of the sun. So when it travel for the long distance, shorter wavelength of blue light are scattered away. The longer wavelength of red light only reach our eyes. So the sun appears reddish during the sunrise and sunset. Why does the sky appears white at noon? When the sun is overhead, as at noon, the light coming from the sun has to travel relatively shorter distance through the atmosphere to reach us. At noon, the sun appears white as only a little of blue and violet colors are scattered. So during the noon time, the scattering of light is less. So the sky appears white. Because it have to travel only the shorter distance. And look at this image. The observer on the earth. The sun near horizon means it have to travel for the longer distance to reach our eyes. But at noon means the light have a shorter distance to reach our eyes. When it is shorter distance, the scattering of light is less. So the sky appears white. When the longer distance, the blue colors are scattered away, the red only reach our eyes. So the sun appears reddish. The activity. In this activity, you have to take the source of light, convex lens, water, cardboard with a slit. Slit means that is hole. The one more convex lens and a screen. And place a strong source of white light at the focus of a converging lens L1. This lens provides a parallel beam of light. So when the light fall on this convex lens, it gives the parallel beam. Allow the light beam to pass through the transparent glass tank containing clear water. Here the glass tank D it containing the clear water. Allow the beam of light to pass through a circular hole made in cardboard. Now when the light passes through the glass, then it come out from the glass and passes through the cardboard with slit. Obtain a sharp image of the circular hole on a screen using a second converging lens. Here I kept the one more converging lens near to the cardboard slit. So the light allowed to the convex lens and fall on the screen. Now dissolved about 200 gram of sodium thiosulfate in about 2 liter of clean water taken in the tank. Now you have to add 200 gram of sodium thiosulfate in the clear water and add about 1 to 2 ml of concentric sulfuric acid to the water. Here I added the two things in a clear water. One is a sodium thiosulfate and another one is a concentrated sulfuric acid. What do you observe? The same light is passing through the water tank also. I think you observe that the red light was on the screen. Why the red is on the screen? And look here. When the light passes through the solution of sodium thiosulfate, the particles present in the sodium thiosulfate are scattered the shorter wavelength of blue light. So the water tank look blue in color and a longer wavelength of red only reach the screen. So the same phenomenon happened in the sun appears reddish during the sunrise and sunset because when the sunlight travel a longer distance, the fine particles present in the atmosphere scatter the blue light and allow the longer wavelength of red light. So the sun appears reddish during the sunrise and sunset. You will find fine microscopic sulfur particles precipitating about 2 to 3 minutes as the sulfur particle begin to form. You can observe the blue light from the three sides of the glass tank. This is due to the scattering of shorter wavelength by minute colloidal sulfur particles. Observe the color of the transmitter light from the fourth side of the glass tank facing the circular hole. It is interesting to observe at first the orange, red color and then bright crimson red color on the screen. So this activity demonstrates the scattering of light that helps you to understand the bluish color of the sky and the reddish appearance of the sun at the sunrise and the sunset. I hope you understood why the color of the sky is blue, why the sun appears reddish during the sunrise and sunset. Thank you for watching.